Okay, the grade 10s, welcome to our second tutorial in trigonometry, and this time we are in question 5, and the following is said to us. They say in the diagram below, P with the coordinates P and Y, X and Y, is a point in the third quadrant. ROP equals beta, and 17 cos beta plus 15 is equals to 0. Write down the values of X, Y, and R. Okay, so let me just try to write down the information, give the Cartesian representation of the statement, and see what we can go from there. In the diagram below, they say P has the coordinates X and Y. Okay, it is a point in the third quadrant. Okay, and they say they say ROP equals beta, and 17 cos beta plus 15 is equals to 0. Okay, and what else do they say? This is Y, this is X, and there's a point with R there. We have our 0. And what else do we have? We have a terminal ray in the third quadrant. The angle runs from 0, lands here, where the entire angle from this to there, it's our angle beta. This is fine. We have our R. This is a point P with the coordinates X and Y, and it is in the third quadrant. X and Y are both negative. Okay, this is fine. This is very good. And what is it that we want? They say write down the values of X, Y, and R. Okay, this is fine. The first thing that I should ask myself is, how do I find X, Y, and R? So X and Y are the coordinates of a point P. R is the hypotenuse. Okay, whether I go this way or that way, we will see. So how do I find the values of X, Y, and R? The very first thing and the visitor would do would go to the equation and will try to resolve this. So I will say 17 cos beta plus 15 equals to 0. 17 cos beta equals minus 15. Cos beta is minus 15 over 70. And cos, this is adjacent over hypotenuse, which is X over R. So it seems like I have X and R, and I know that the hypotenuse is always positive, and X and Y must be negative in the third quadrant. So I can say, therefore, X equals minus 15 and R equals 70. Now I need to find the value of Y. I need to complete a triangle here. Now, do I go this way or do I go that way? So the entire of this is beta. It runs from here to there, so you can close it this way. You have to close it that way so that beta is inclusive. The angle here is part of beta, so it is in essence beta there. Okay, and then when I close there, I have an angle of 90 points to the hypotenuse of 17. I have my value of X, which is minus 15. So I can find the opposite using the theorem of Pythagoras. X squared plus Y squared equals R squared. Theorem of Pythagoras is my reasoning. My X is minus 15 squared. Y squared equals 17 squared. I want to make Y squared the subject of the formula. Y squared equals 17 squared minus 15 squared. Why am I writing it like this? Any number that is inside of the brackets squared will give a positive number. That is why I'm doing this. This negative is a negative of you bringing this into this side, but it is already positive, because anything negative squared, it's a positive. You would know this. So Y will be the square root of 17 squared minus 15 squared. Let me just go to the calculator very quickly, try to find what the value would be. So here we are, and we are therefore saying what is the square root of 17 squared minus 15 squared, and I find the value as plus or minus 8, because remember, when we take the square root we find two answers, a positive and a negative one. So this is plus or minus 8, but I know in this quadrant y it's negative, therefore y is minus 8. So my x equals minus 15, y equals 17, sorry, r equals 17, and y equals minus 8. So I was successfully able to find the values of x, r, and y. Okay, that was a very easy problem. This was just a basic problem, even though it is exam related, but it is very, very basic. Okay, that is fine. Now let's continue with this. Let's go to 5.1.2. Let me just zoom in the problem. Right. In 5.1.2, what can we expect? They say, without using a calculator, determine the value of sine beta. Sine of beta opposite over the hypotenuse. So here is a beta. There it is inclusive also in there. So that would be opposite. And my opposite is minus 8 over the hypotenuse, which is 70. Now we find, and let's go, that was 5.1a, and now let's go to 5.1.2b. They want cos squared 30 times 10 beta, and 30 is a special angle because the special angles are 0, 30, 45, 60, and 90. Okay, so cos squared 30, this can be written as cos 30, that is a squared, multiplied by the 10 of a beta. Okay, this is fine. I can cope with this. So since it is a special angle 30, you just go to your calculator and you just say the cosine of 30, and you will find root 3 over 2, and that needs to be squared. Okay, times the 10 of beta. So the 10 of beta would be 10, it's adjacent, sorry, 10, it's opposite over adjacent. Opposite, which is minus 8, over minus 50, because I know that 2 are its opposite over adjacent. So the opposite, it's minus 8 over the adjacent, which is minus 50. Okay, and when we are in there, what is it that we can do? The square root of 3 squared is 3, 2 squared it's 4, times 8 over 50. Okay, 4 into 8 goes 2 times, so you have 3 times 2 over 50. And what else can we say? 3 over 15, 3, 6, 9, 12, 15. You will have 1 over 5, which is 2 over 5. I think so. I think this should be the correct answer. But let me just verify. Let me just verify this. 3 over 4 multiplied by 8 over 50. and we find an answer of 2/5. So we are very good with this. So that was 5.1.2b. We can go to 5.1.3. 5.1.3, calculate the size of ROB correct to 2 decimal places. So they want the size of ROB. So what were we told? We were told that R in triangle ROB, angle O is beta. So we have ROP. So there it is. So what is it that they want here? They are looking for this angle. Which is angle beta. This is angle beta, of course. It runs from 0 to here. So when we say ROP, we simply mean the angle here, which is angle beta. Okay. Now I want you to see something here. If you calculate the angle here, I want you to see something. If you find the angle here, that would be fine because you can use trigonometry. Obviously, you've been doing that throughout here. And here you can find the angle here, and the angle here together with the angle, this angle, it's 180. Can you see that? We don't even have to calculate this. This is a straight line angle of 180. So this is 180 plus this piece, and that will give us the entire ROP. So we are expecting a value that is bigger than 180. Let's see if this will work. Let's start first by finding the angle here. And how do we find the angle there? We can say, we can use the tan. We can say the tan of beta being the angle here. Okay. Or let me just use a different alphabet. Let me say alpha. Tan of alpha, whatever, whether you face this or whether you face that, I do not care. But this is the angle here. So let's say the angle here is alpha, facing wherever we wish. So the tan of alpha will be the opposite over the adjacent. So opposite will be -8 over adjacent will be -15. Remember, that is the tan of alpha. Can you see what I do? I end up as zeta. You do as you wish, man. Right, so this is 8 over 15, and then alpha will be arctan of 8 divided by 15. So let's just find the angle very quickly. So arc, you press shift on your calculator, then you press 10. It will raise that 10 to exponent of -1, and then you say 8 divided by 15. And what value do we have? We have a value of 28.073 degrees, and this is making a lot of sense because this angle is highly probable that it could be in that value. Okay, so beta will be equals, because beta will be 180 plus 28.073 degrees. So I can just come here and say answer plus 180, and I will get 208.073 degrees as the value of beta. And when you look into the diagram here, obviously that angle must be less than 270. There it's 270. From here to here it's 270. So from here to here, it's highly probable that it could be 200 and something. Highly probable. So this is all, to be honest, guys, that I wanted us to look at in this trigonometry. And since we are done, I will see you in the next tutorial.